Okay, let's look at the final exam test review question. In the meanwhile, I want you guys to go ahead and interpret what's going on in the questions, like the as I shown you over there. So basically, what this is a small. So what's going on is a small block mass M is released from rest at the top of the curved frictionless ramp shown above, which is just like what you see over there on the top left corner of the black poster, and the block slides down the ramp and is moving with a speed of 3.5 v naught, which is the initial velocity. When it collides with a larger block of mass 1.5 m at rest, at the bottom of the incline, the larger block moves to the right at the speed two times of the initial velocities. Immediately after collisions, express your answer to the following question in terms of giving quantities and fundamental constant. So question 1 is determine the height of the point from which the small block was released. And question number 2, which is B, is determine the speed of the block after collisions. So from that, we're just gonna go ahead and approach the problem this way. As you can see that the block of mass 1m of the m is lying down the ramp that has the height of h. After that, what happened was the block m will continue moving at a certain speed. That's what we're looking for. And also the block of 1.5 m, which is a little bit heavier than the block that is lying down the ramp, will continue moving at a certain velocity. So question A is determine the height in which this height, which is the h, in which the block of mass m is released in order for that to happen. So now we're just gonna go ahead and look at the fundamental concept, which is the change of energy. So I'm just gonna put 1 and 2 as a point of reference. So the change of energy, which is the energy which is at point 1 is equal to the change of energy at point 2. So basically I'm saying that the change of energy initial it must be equal to the change of energy at the final position, which means that the energy is conserved. That's the main idea that you need to know. And let's go ahead and look at what types of energy do they have, does this block have. So this block right here not moving at the point, at the time, so that block itself is at certain height, so therefore it has potential energy, which is mgh. And then once it released to the bottom of the ramp, with due respect to the point of reference, so there's no potential energy because that potential energy is equal to 0. As you can see, the measurement is from base of the ramp to the top of the ramp, h. That's what it is. You have kinetic only. So in order for you to figure out what height is, you're gonna have to manipulate the equation in such a way that you will isolate h by itself. That's how I did it. So basically I move mg over there to divisions and I cancel m out, so that what happened there, I scattered out the m because it's the same mass, the same thing. So my height is equal to 1/2 velocity squared divided by g. So at certain conditions, let's go ahead and not worry about these values. Let's go ahead and continue to part B, where you have to determine what velocity of block this one is moving, knowing the fact that when it releases over here, you know the fact that that velocity is equal to 3.5. So you know that the initial velocity of this one when it goes down the ramp is coming down with the certain velocity, which is 3.5 v naught. And at that point in time, this block of mass 2 is equal to 0. On the mass 2 itself is equal to 1.5, but the velocity is equal to 0 because it is at rest. So as you can see, I can do that one. So let's go ahead and be more specific in terms of potential energy. You know, the change of momentum is equal to the change of momentum at the final one. So initial is equal to final, and momentum is reserved, just like what we were talking about. So let's go ahead and iterate what the equation is. You know m1 is m. So let's replace m1 with m. And you know velocity 1, you know from the questioning that when this block right here goes down the ramp, it goes with a certain 3.5 velocity v naught. And that is 0 because it's at rest. And then you know m1 is m. m2 is 1.5 m. That's how you replace this variable, values and variable. And you're looking for v1f final. How fast this block is moving, whether it's moving or not, at certain velocity. And you know, from reading the question itself, it tells you that this block right here will move at 2 v naught. And now you're going to rearrange the equation in such a way that you will figure out that Vf is equal to 0.5, which is 1/2 of initial velocity. Now go ahead and look at questions. I believe it's question D, to figure out how much of the coefficient of the friction is. So let's go ahead and interpret this. This block right here, after certain collisions, this one will move at certain 1 right here, just like what we did there. And then but this one right here, the block of 1.5 m will still continue moving at a certain velocity. And then when it passes through the rough surface, with certain coefficient, that's what you're looking for, then eventually the box itself will come to rest. So you need to learn the new concept, which is work is equal to the force times distance. So the force right here, since the object itself is on the ground, so you have the force due to the gravity. That's why I'm putting down mg right here. But then I'm replacing my m, since my m is 1.5 m, so I put my m there is 1.5 m instead of m, because it's very specific to that points to the mass. And then this is like the force of friction is mu n, and n is equal to mg in this case, times distance, equal to the change of kinetic one. Eventually it comes to rest. Therefore I just get rid of that term right here. But you know the certain velocity right here at the very beginning, you know, so as if you can tell, so that velocity right here that you were looking at is 2m. Is 1.5 m, which is 2 v naught. So basically, that velocity itself, when you replace this one, you will replace this one with certain condition, which is 2 times v naught, so here squared. So basically, it's not x, it's like velocity squared. That. This is how you calculate mu. I move all this variable 1.5 mgd over here, and I cancel the m out. Therefore, I get the mu, which is the coefficient of the surface, will be equal to 1/2 velocity squared divided by gravity divided by distance. And the question is whether or not these collisions is elastic or inelastic collisions. So I came to a conclusion where it was elastic one, because both masses, first of all, don't stick together, and second of all, it comes with different velocity. Hope it's helped.